Hello mathematicians, today we are going to be talking about solving radical equations when the radical is isolated. So at the end of this lesson, you'll be able to solve radical equations when the radical is isolated. What is a radical? A radical is a symbol that denotes a number, or denotes a root of a number. So for example, you'll hear us say square root, cube root, fourth root, fifth root, so on and so forth. This is what a radical looks like. So my black line there, it kind of looks like a division sign, but it also, or division operation, but it has this extra little leg in the front that tells us that it is a radical and not division. The number on the inside is called the radicand, and then the little bitty number is called the index, and the whole thing is a radical. Square roots rarely, if ever, show the index number. So if the index number is missing, then that means it is a square root. So that index would be 2. If it's anything other than a square root, the index number will show. But mathematicians are lazy and we don't like to write things that we don't have to. All right, so let's start solving. The opposite of a square root. So the reason I know it's a square root is because that index number is missing. So we know that that's a 2. So that's a square root. So the inverse operation of a square root is squaring. So I cannot do anything with that in because it is trapped inside this radical. So I have to undo the radical before I can do anything with that in. So the opposite or the inverse of a square root is squaring. So if I square this side to get rid of the radical, we are still solving equations. So anything I do on one side, I must do on the other side. So I also have to square that number. Remember that squaring or exponents are repetitive multiplication of that base number. So this is really telling us 7 times 7, which is 49. Bring the equal sign down. And these are inverse operations, so they just go away and we're left with n. N is by itself, so our final answer is 49. All right, let's check our answer. So we have 7 equals the square root of 49. Well, what is the square root of 49? Well, we know that 7 times 7 is 9, but we can also use our handy dandy calculator. So we type in 49 and take the square root of it, and notice that it's 7. So the square root of 49 is 7. 7 equals 7. Therefore, our answer is correct. Let's take a look at number 2. So I look at my problem. I have this radical here, so I cannot do anything with that 32x until the radical is taken care of. You cannot work inside of the radical. So the opposite of a square root is squaring, but if I square this side of the equation, I must square this side of the equation. A square root and a square are inverse operations, so we're left with 32x, and 8 times 8 is 64. X is not by itself yet. I still need to separate the coefficient from the variable. And in this case, the coefficient is 32 and our variable is x. So I'm going to divide by 32 on both sides. And I get x equals, so 32 goes into 64 twice. But if you didn't know that, you can always use your handy dandy calculator. 64 divided by 32 is 2. Let's check our answer real fast. So we think that our answer is 2. We're going to work from the inside out, just like we always do when we're checking. So we still have this radical here. We still have equals 8. 32 times 2 is 64. And now the square root is 64. If you don't know, the the squares off the top of your head, you can use the handy dandy calculator. The square root of 64 is 8, so that equals 8. The right side is 8, and 8 in fact is the same number as 8. So our answer is correct. Let's move it. All right, there we go. Let's go through another example. So again, we're looking, our radical is isolated. So we can't do anything with that 2x plus 110 until we take care of the radical. It is a square root, so the opposite of a square root is squaring. Square root and squares are inverse operations, so they undo each other, leaving us with 2x plus 110. And 10 times 10 would be 100. And what we're left with now is a two-step equation. So I know my goal is to get that 2x by itself first. So I'm going to subtract 110. Bring 2x down. 100 minus 110 would be negative 10. And then my final step would be to separate the coefficient from the variable. The coefficient in this problem is 2, and our variable is x. So I'm going to divide by 2. And 2 goes into negative 10, negative 5 times. Let's check our answer. Anytime that we are checking, we are working from the inside out. So inside of the radical, I need to take care of the multiplication first. So I still have this radical, I still have that plus 110, and I still have equals 10 over here. 2 times negative 5 is negative 10. I still have the radical, I still have equals 10. Negative 10 plus 110, so that's 110 minus 10 would be 100. And if you don't know your perfect squares, you can always use a handy dandy calculator to help you figure it out. The square root of 100 is 10. And the right side of our equation equaled 10. So this is true, meaning that our solution is correct. Let's get one more example in, and then it will be off to the races for you guys. Okay, this one, we have two radicals on both sides of the equations. Well, I know in order to undo this radical, I need to square it. If I square the left side of the equation, I must square the right side of the equation. This is an inverse operation, leaving us with n. Squaring a square root is also an inverse operation, leaving us with 3n minus 20. And now we solve. We have variables on both sides, so I need to move this 3 over. So I'm going to subtract 3n. n minus 3n is negative 2n. Bring down negative 20. And my final step would be to separate the coefficient from the variable. And in this case, our coefficient is negative 2. And n equals a positive 10. Before we're feeling confident about that, let's check it. So I'm going to leave this one as radical 10 for now. But I'm going to simplify the inside. So 3 times 10 is 30 minus 20. 30 minus 20 is 10. So notice I have radical 10 equals radical 10. That's equal to each other, so that is the correct answer. All right, make sure you look for a couple of examples and then do some practice problems. As always, happy mathing!